Okay, today we're looking at complex numbers, so we want to be able to perform operations with complex numbers. And we have a little bit of vocab here. So the imaginary unit is I. So now we are talking about, everything we've talked about so far in math has been real numbers, and now we're actually going to talk about imaginary numbers. So I is equal to the square root of -1. You've always learned that you can't take the square root of a negative because it doesn't really have like a real meaning, but now we can do that using the fact that I is going to be equal to the square root of -1. So the opposite of that then is if I squared both sides of this, I squared is equal to -1. So a complex number has a real part and an imaginary part, and then the complex conjugate is where the real part stays the same and the imaginary part switches signs. So we'll use that a little bit later here. So simplifying each of these expressions. So we have, the first one is the square root of -100. So I'm going to break this apart into the square root of -1 and the square root of 100. I'm taking out the square root of -1 because it has that negative underneath of there. And this is equivalent to this because -1 times 100 is -100. So now I can say, well, the square root of square root of 100 is 10. And the square root of -1 is I. And when we take a square root, we always have positive and negative. And then the way that they will write this is the real part will come before the imaginary part. So positive and negative 10i is what that would simplify to. Okay, so square root of 28. So we looked at two different ways to simplify square roots. You can do the quick way, where you just know all of your factors right off the bat, or you can do kind of the factor tree method. So here I'll show the quick way, and this will be factor tree. Alright, so first, since I have the negative underneath of there, I'm going to take out a -1. Now 28, I know is divisible by 4, and 4 is a perfect square, so I'm going to say 4 times 7 is 28, and the -1 gives me the negative sign in there. So now I have, this becomes I, this becomes 2, and the square root of 7 you can't do anything with. And the way that this will be written would be 2I root 7. That's just the order that you're going to see it in. Okay, so now I'll show you the factor tree method on here. You could do either one. So if I break this down, I would, first of all, I'm going to take out that -1. And now if I break up 32, I could say that's 2 and 16, 2 and 8. So now I'm taking my pairs of 2's. So I have 2 pairs of 2's on the outside and the 1, 2 that was left over here. So this one has to stay under the root. These two can multiply together on the outside, so 2 times 2 is 4. And then over here, that became the I. So this one would be 4I root 2. Okay, so when we're multiplying them, here I have a -3i times a 2i. So you can kind of think of the i's as variables on here. They work very similarly. So if I have a -3 times a 2, that's going to be -6. I times I is I squared. And then if we note back up at the top, this is important, whenever you have I squared, that's equal to -1. So I'm going to take this I squared, and I'm going to replace it with a -1. -6 times -1 is 6. So -3i times 2i would just give me a plain old 6 if I simplified that. Okay, on here I have the square root of -12 times the square root of -2. So with square roots, when I simplify that, that just becomes the square root of +24. And then we can simplify this one. So I'll show both methods here. So 24 would be 4 and 6, which means that is 2 root 6. So that's the quick way. The other way is break it up piece by piece. And you can see I have 1 pair of 2's that comes outside, and these are the 2 things that are left on the inside. So it's the same answer either way here. Alright, so example 2, performing the indicated operation, we have addition, subtraction, multiplication, and division here. So addition works exactly like you think it would, and same with subtraction. So we're just really combining like terms. So I have a 3 and a positive 2, so that's going to give me 5. I have a 5i and a minus 4i, so that's going to be plus 1i or just plus I. Subtraction. Whenever I do subtraction, I usually like to rewrite it by distributing that out, so it switches the sign of everything behind it, and now I'm going to combine like terms. So I have a 4 and a minus 3, which is 1. I have a negative 6i and a positive 7i, so that's 1i again. That's a coincidence that these both ended up being just plain i's on there, just so you know. Alright, part C, multiplying. So here we have to do either the FOIL or the box method on here. So if I do FOIL, I will do first, 3 times 5 is 15. Outside, 3 times negative 2i. You can multiply a real number and an imaginary number, so that's going to be negative 6i. Inside, 4i times 5 is 20i. And last, 4i times negative 2i is negative 8i squared. So now we're going to combine like terms, which we have here, and we're going to replace this I squared. So the negative 6 and the 20 is going to be 14i. And then this, whenever you see I squared, becomes negative 1. So now I can simplify a little bit further. This is a negative 8 times a negative 1, so that's going to be positive 8. And then these two can combine now, so that's going to become 23 plus 14i. Alright, and the last one, part D. So this is where that complex conjugate thing comes in that we wrote down at the beginning. So a complex conjugate is what you have to use when you're dividing. So you're going to multiply, I'm going to write this on here, multiply by complex conjugate of denominator. So that means the complex conjugate is where the real part stays the same and the imaginary part switches signs. So I have to multiply that on the top and the bottom. So if this is 3 plus 2i, the complex conjugate is 3 minus 2i. Okay, so the reason I can do this is because anything divided by itself is really just 1. So what we're doing is really just multiplying by a really fancy version of 1 in order to simplify this. So this 5i is going to distribute out to these. So I have 5i times 3 is 15i. I have 5i times negative 2i. And then in the denominator, I'm going to FOIL again here. So I have first, I have outside would be 3 times negative 2i. Inside, and last, 2i times negative 2i, negative 4i squared. And now we're going to simplify all this stuff. So if I come down here now, I have a 15i minus 10. The I squared, whenever you see that, is negative 1. Denominator, these cancel out. That's really handy. So now I have a 9, and I have a minus 4, and I'm going to replace that I squared with another negative 1. So negative 10 times negative 1 is positive 10. I'm just writing that so that the real part comes before the imaginary part. And then on the bottom, this is going to become a 9 plus 4, which will be 13. And since none of those things share a common factor on here, like 10 and 13 don't share a common factor, 15 and 13 don't, that's as simplified as that answer is going to get. Alright, so you have 2 to try. You have one that's just simplifying and one that's multiplying on here. So I would use this as your example right here for number 2. Okay, and you need a joke. What kind of bee can't make up its mind? That'd be a maybe. Okay, I hope you have a great rest of your day and make sure you're kind to someone today.